This is called How We Turned That Little Green Man. A lot of people asked me what that little green man was, and thinking to myself, it's a mobile track. What else is going to be? But it's Android for those of you who can't figure it out. Again, my name is Matthew Raleigh. My Twitter handle is 1T, and I'm a senior security consultant at Modisano. This talk is just basically a bunch of techniques on how I reverse engineer Android applications with specific examples, and at the end, there's a new tool that I've been working on that I'm going to give you guys the ability to download. First, talk about how to gain man-in-the-middle from SSL communication stream in Android. Then move on to static analysis and give you an example of reverse engineering the Skype application and the secret menu that I found in there. Then talk about how to modify an APK without having a source to it, and the ability to inject arbitrary Java into an APK. Then talk about some manual debugging and automated debugging of applications without actually having access to their source code. So the first technique is gaining access to SSL communication stream. I'm assuming that everyone here knows what man-in-the-middling an SSL communication stream entails. However, I'm not sure that everyone has done it on an Android device. The Android operating system works kind of like your browser. When you view an untrusted endpoint, it's going to check its local trust store, and if that endpoint is not trusted, it's going to throw an exception. It's up to the developer of the application whether or not what to do with that exception. Typically, they just fail close, and you can't just put this behind some man-in-the-middle tool that creates custom self-signed cert for you. The red line in that diagram at the top is the cert that's coming back from the attacker of what you're going to actually, what's going to be coming back to the Android device and what you're going to have to force it to trust. Two tools that I typically use to do this are Mallory and Burp. Mallory's uses IP tables to do a transparent proxy, and then Burp is, I'm sure everyone's used it. So again, SSL is handled by the Android operating system. However, there's an option for developers to take control of that negotiation. But this presents two problems when trying to gain access to the SSL communication stream. Is one, how do you convince the operating system to trust the endpoint that you're communicating with? And two, if there's a developer check, how do you get around that? So first, the operating system checks. It's got the Android operating system has a local trust store. There's two different versions depending on which version of the operating system you use. There's no interface for installing this stuff. It's either a bouncy castle file that you have to import the cert into, or a directory that has text-based certs. Before Ice Cream Sandwich, this was the set of commands you'd have to use to actually install a cert onto a device, and then reboot the device. You have to install the Bouncy Castle libraries, pull the cert, use Bouncy Castle to import your cert, remount the system partition to have read-write access, pull the current CA cert, or change the permissions for the current CA cert, push the new one up, and then change the cert, change the permissions back. The tool I wrote, AutoTool, with Ice Cream Sandwich, it's a little bit different. You can just use OpenSSL to generate the text output, and you push the file back up into the CA certs directory. This is the tool I wrote that automates this pretty easily. Pull down menu, double click the file, and it's installed. It currently only works with prior to Ice Cream Sandwich. I'm working on the fix to determine which operating system is being used, and it will determine how it needs to install it. Unfortunately, after that, you have to restart the device. And with the emulator, after you restart the device, the system partition defaults back to whatever is specified on the emulator command line, or the default one in the configuration file. Prior to revision 17 of the emulator, it would actually, if you specified a system partition or a system image file, it would persist changes to that. After 17, it stopped doing that, and I'm not really sure if that's a bug or a feature. I was talking to one of the developers, and they said it was a bug, then they never got it fixed, and they stopped responding to my emails, and not quite sure exactly what's going on with that. But You can use unyaps and make yaps to image to pull apart the image file and put arbitrary files in it. And then again, ice cream sandwich, it switched to bouncy castle or switched from bouncy castle to just a directory of text files. The easiest way that I found to work around this system partition persistence, or requiring the persistence, because after you install this, you have to reboot the device for the cert to be trusted or the change to take effect. At least in Unix and or Linux and OS X, when you start an emulator, it copies the system partition into a temporary directory, which is temp android dash your username and then emulator dash some random string. You can, after you make changes to the system partition, you can copy that locally somewhere before powering off the device. And then next time you start the emulator, you specify the system command line option with that file as as one of the arguments, and then it will take that and do that copy into the temporary directory. So all your changes will be in effect if you use that specific image after you changed it. So I was thinking to myself, if I was a developer and I didn't want someone to modify my application, I would, or if I didn't want someone to gain access to the SSL communication stream, I would implement this X509 Trust Manager, which is a way that you can modify the default operating system or inject code into the default operating system checks on certificates. And this is something that I see a lot in a lot of applications. I'm not sure if it's people trying to prevent this stuff or if it's developers that need to communicate with an untrusted endpoint and don't realize how to do it and leave those checks in. But you can get around this by using backsmall to decompile the application, then you can modify that small source, re-small it, and repackage and re-sign it. This is a set of commands. If you were to do it on a command line, you'd have to, again, pull it apart, find the class that does this custom cert check, repackage it, generate a key to sign it, then re-sign the application, and then install it. With the tool that I wrote, made it a whole lot easier. You can load an APK directly from the device. And here, this is just an application that I wrote that has a X509 Trust Manager in it. You can search through the backsmall source for the X509 Trust Manager, double-click it from the search, modify the method to return void. It's a void or return, just return before it actually does the check. If something goes wrong, it throws an exception. It doesn't return true or false. You can then build it directly from here, which allows you to sign it and generate a key store to sign it with just some checkboxes. A whole lot easier than trying to remember all those command line options before. So now that you have man in the middle, you can man in the middle of this communication, what can you do, and what does this give you access to? Typically, after gaining access to this, you're not going to be attacking the device anymore. You're now going to use that communication stream to attack these backend services or backend servers. What I've seen is that developers who create these backend services expect all the communication to come from an Android device, and it's correct format. However, as we know, correct format isn't always going to be the case. So some of the things that I've been able to do from just gaining access to man-in-the-middle SSL stream was 101 read-write access of files through a SOAP interface, XML entity inclusion that allowed me to eventually gain access to the admin SSH private key, which was used in their entire infrastructure, and the ability to lock or wipe someone else's a device through software. It was a security software, so if you lost your phone, you could wipe your device through a web interface. Now, again, if I was a developer, how would I prevent this? And the problem is that there's really no way to 100% prevent this. At some point, someone's going to be, if someone's dedicated enough, they're going to be able to find a way to see your network communication stream. And you have to remember that this device is outside of your trust zone, so you can't control who's using it and what they're doing with it. So it's just like cross-site scripting or SQL injection. You always have to treat the input that you're getting from a user as untrusted. However, you can make it really hard for people to reverse engineer your application. The biggest thing that frustrates me is when people get the expensive obfuscation software. As you'll see later on, there's really easy ways to get around obfuscation by using strings, static strings as reference points. But with the expensive software, it actually obfuscates the strings as well. So you can't just grep through source code to find what you're looking for. Again, implement custom cert checks like we showed before. And a new thing that I actually haven't seen implemented anywhere, but to me seemed pretty obvious, was to authenticate the application itself through every network request that it's gonna pull. So the APK has access to itself. You can do some sort of custom hash with every request. So when you send that, you can ensure that the application that's communicating with your endpoint has not been modified in any way. I'll show an example of how to get around that though as well. So the next technique I'm going to talk about is static analysis. And static analysis, I feel like in general, is a skill. Everyone does things different ways. There's different paths to get to the same endpoint. But I'll show you guys how I go about doing things, and hopefully it'll help you in the future. First, every project that I start with, I put into a specific directory structure. 4 directories: jar, source, unapk, and unzip. There's a tool, dex2jar, that will convert an APK file to a jar file. I then open that up in JD GUI that will show a somewhat decompiled source of the APK. Then the unapk directory has the smalley source, and the unzip directory just unzips the APK. This is a script that I use that just kind of automates everything. Again, I have all the command line stuff in here just for reference if anyone. I actually go back to this a lot to try to figure out what commands I'm trying to run, because it's impossible to remember all this stuff. So when I was looking at the Skype application, I saw in logcat messages that it was trying to access Skype.properties file from the SD card and from a specific local to the application, and I couldn't see it anywhere, and I was curious as to what that actually was and what it did. So when grepping through that directory structure that I set up before, I was looking for just the static string Skype.properties. So the Skype application is very, very obfuscated. However, they don't do the string obfuscation. And as you can see here, just grepping through the source directory and the \smalley directory, you can see Skype.properties comes up in some of the smalley files. But doing this setup, I also had the Java directory, or the source directory, which has the decompiled Java source as well. And I thought to myself, why is this coming up in the smalley source but not in the Java source? Because I would much rather look at Java than smalley. After looking at the two methods in the exact same class, I noticed on the top, which is smalley, where you can obviously see the Skype.properties string, the bottom actually had an error, and it just shows the bytecode that doesn't reference the string at all. So this kind of showed me a very important lesson, that you can't always rely on this decompiled Java source. You actually have to go back to the smalley source at some points. This is one example of when I had to do that. After looking through the smalley source, you can see that it's this typical Java properties file. It's got key value pairs, and you can see it looking for a specific string like login, and then setting that to a variable, and then the type of the variable that it is. So looking through all these, I wanted to test to ensure that my reverse engineering is proper, and I'm actually looking at what I am expecting to look at. So the one thing that stood out to me was this debug menu, which is halfway down the list. So I tested that. I created a file, put it on the SD card that just said debug menu equals 1. Next time I opened up Skype, I saw a debug menu down there, which was awesome. It gave me some extra options like logging. But then on the right screenshot, there was a weird button at the bottom that just says emergency call American Airlines. It actually calls American Airlines, not through Skype with the phone. Still to this day, have no idea why it's there. But it's cool. It gives you these logging options. So enabling those and running the application, you can see this is a second of logging while those are enabled. And you notice it's a verbose logging, and then it gives you the exact class of where each log message was coming from. And what we did before was take the static string Skype.properties and then grep through the entire code base to try to find out where that was located. This is the same concept here, except for now they're giving us the exact classes and exactly where all this stuff is happening. So for example, at the bottom there's get conversation message. If I want to know which obfuscated class is dealing with getting messages, found it. They told me it in the logging. So again, thinking about as a developer, how would I prevent this, or can I prevent this? If someone wanted to reverse engineer my application, again, you can't really. It kind of comes down to a cat and mouse game, unless you're willing to write your own decompiler. But you can again make it pretty hard for someone, and real obfuscation makes it very, very difficult. When you can't have these static strings as reference points, it's almost impossible to search through the code. Again, disable logging is very, very important. It doesn't give you any reference points to when you perform an action. So like, if I click a button and then all of a sudden it spits out a log message as soon as I click that, I know exactly in the code where to look for what that button actually does. And at Black Hat this year, there's a really cool talk called Practicing Safe Dex that showed techniques that would cause the decompilation tools to fail and crash, but would allow the application still to run in on the operating system perfectly fine. It reminded me of old anti-reversing tools in the Windows days. They would create a class that had an invalid bytecode in it, and it would never be used through the application at all. However, when the decompiler parsed the entire file, it just bonked and threw an exception. There's a proof of concept tool, AppSecUSA, as well for that talk. There's links at the bottom, the presentation and the tool. Really cool stuff. I'm not really sure how practical that is in a real life environment, but this is the cat and mouse game. As soon as I figure out a way to cause your tool to crash, you're going to figure out a way to cause it not to crash. But just ideas. So at Monticello, we create challenges for each other, and unfortunately can't talk about client work, so I had to create this application as a challenge that I'll show you how to get around the controls that I put in place. It's called Hacker Challenge. There's one screen, as you can see on the left. It shows a picture of the Hackers movie, and all it does is performs SSL communication with an endpoint, and it pulls down a quote-unquote secret, which is just like a quote from the movie based on one of the characters. And the goal is to try to figure out all of the secrets for all the characters, and this is all you get is this one button, which will pull down zero cool secret. It's got two preventative measures. One is the custom hash of itself, like I was talking about before, so it kind of authenticates itself prior to communicating with the endpoint, or while communicating with the endpoint. And as you can see on the left, the error message comes up if you try to use a modified version. It'll say you modified it, we're not going to tell you anything. And it has a custom X509 trust manager in it as well. So the next technique I'm going to talk about is modifying an application. Typically, like I showed before, when I modified an application, I would just decompile it into source, or into the Somali source, and then modify that. However, it's like modifying a binary in a disassembler, like just looking at the bytecode. It doesn't. Why can't I just put Java right in there? So this is what's going on in my mind. I want the Java to just get right into that APK. I don't know how to do that though. So the logic of a normal compilation path is for a Java application, or for an Android application, is you go from a Java file, you use JavaC to convert it to a class file, then it uses DX to convert it to a DEX file, and then it's zipped up or into an APK, essentially. There's some other details, but it doesn't really matter when it comes to this. And then when the modification of what we were talking about before, or what I showed before, was you take an APK, you unzip it to a DEX file, you use backsomali to convert it to a Somali file. That's when you do the modification. Then you re-Somali it to a DEX file, zip it up back into an APK. And then you obviously have to re-sign it and stuff, but again, details that don't really matter in this. So taking those two paths, I found that you can go, on the top is the normal, how you'd pull apart an application, modify it, and then put it back together. On the bottom is a modified version of the normal compilation path. If I can get to a common DEX file and then get them to their Somali format, I can hopefully just merge those back together into a DEX file and back into an APK. So I want to be able to write Java source file and put it into an APK that I don't have source code to. Turns out you can, but there's a few nuances that make it a little bit difficult. One is the calling convention that Somali uses. I'm not even sure where Somali came from now that I think about it. It's like a mix between bytecode and Java. It's hard to read and hard to mess with, but anyways. And you also have to take into account namespaces. So if I add a method to a specific class, I have to make sure that when I call that method, I'm calling it in the correct namespace versus the namespace that I define. So in that Hackers Challenge application, it does a custom, like I said before, it does a custom hash of itself, which authenticates it to the endpoint. So this is, as you when you click the button, it says I don't play well with others. So that's when it successfully authenticates with the endpoint. In OtterTool, you can load the APK directly from the device, which gets into its Somali format. And I'm trying to find this hashing out. So the goal of this, the goal of this whole video is to try to modify the APK to print the hash that is being used to send with network communication. So I find the method called getFileHash, and I can see that it does some stuff, and then it's going to return an object v2, which is going to be a string. See right there. So in this other tab, you can actually take Java. On the left-hand side is just Java. I'm going to create a method that just logs a string. So I've got 1t-debug as the key for the debug message, and then the argument that's being passed to this method. So after modifying this, I can convert it to Somali, which on the right-hand side will do what I was talking about before. I can now take this method directly from there and paste it into this class at the bottom. From there, I have to use the correct calling convention. That's why on the left-hand side, I called the method in the main, is just so I can see a reference of how that method is going to be called in Somali, because I don't know why it even looks like that. But so after that, you can just copy the calling convention and put it back. So go back to that return value that we want to be able to see. And prior to returning, just simply change the argument to v2 because it's returning v2. And like I said before, you have to take the namespace into account. Right now, the namespace of that is OtterTool, and it's in a class called Hacker Challenge Android Activity. So after we change that, we can save the file, and then rebuild the APK. Which will automatically sign it and generate the key store for you. From here, uninstall the old APK from the application, from the emulator, which is running in the background.
Will this change cause the hash value different?
Yeah, that's gonna be the next demo. Well, cause the hash value of what?
Self-measured hash.
Yeah. So yeah, you mean the application is authenticating the endpoint, so its hash isn't going to be the same, and then it's going to give an error. Yeah. But this will allow me. This is more of a demo showing how you can modify an application just by input from Java source code. So what we did was just logged a message that said 1t debug. Now when running the application, when you call that, it's going to see, like what we were just talking about, it's going to throw an error, or we were able to successfully modify the application to have it debug a message coming from Java source code. Without modifying or creating anything in Somali, we just went from source directly to a modified APK. So what does that mean in my mind? It means that any APK that's out there can be modified. And the Google Store, the marketplace, doesn't have checks in place like Apple does. I know there's the new process, but what's preventing me from pulling an APK down, modifying it with a whole set of libraries that I control, and then putting it back up there? Really nothing. Also cracks for applications that you need to activate. Essentially, you can put any Java into any APK, which is pretty cool. The next technique, so since with that application, now it failed to authenticate itself to the endpoint, and thus we got the error that said the APK has been modified. But Android operating system provides you with a whole debugging architecture. It uses the common Java platform debug architecture, which has an API. Eclipse manages it well. There's a JDB, which is a command line interface, and there's a JDI hook, which is a Ruby implementation of a Ruby linking to the Java API. The only problem with this is if you don't have source, you need to know exactly where you're going to break on these in these applications in order to see, for example, the key that we're looking for before. So you can. This is a demo of how we can use Eclipse for an application that we don't have source to modify or to view the hash that we're trying to find. Since the application can't be modified, we need to find a way of getting that hash because it's a custom hashing algorithm. We can't just, it's not an MD5. So first thing you do is decompile the application into the Java source. This is the script that I showed in the beginning of static analysis. But save that source from JDGUI into a directory that's just showing the Java files. In Eclipse, we can create a new Java project, and then copy the source that we just decompiled into that project. Now, and after doing that, we refresh the project in Eclipse. It's going to show that there's a whole bunch of errors, but we don't care because we're not actually going to be running this application. We're just using this as like a stub for the debugger on where we want to breakpoint. So that the same method that we modified before, this get file hash, you can't really tell right there, but I double-clicked on the left-hand side, and there's a blue dot right here now. That's saying create a method breakpoint at this specific method. There's in the Java debug architecture, you can create breakpoints on methods, and you can create them on line numbers. So in order to do one on a line number, it's not going to work because the source isn't the exact source that that was used to compile the application. But the methods we can actually breakpoint on. So after double-clicking that in the debug view, you can see that that method was the breakpoint was created on that. So we want to see the return value, so we want to have it break on exit, which is that return string. So this is just showing that method as what it actually does. It iterates through a string and then does something, concatenates to it, and then returns that value. So in the emulator, I don't know when this changed, but in the development settings, there used to be this option to debug an application. You can select it and then force it to wait for a debugger prior to running. The new versions in Ice Cream Sandwich don't actually have a GUI to do this, but I'll show you the command line way of doing it. So you select the Hacker Challenge, click Wait for Debugger, and then when you run it, it's going to show you a dialog box saying, I'm paused waiting for a debugger to attach before I can continue running. Now in the DDMS view, you can see that there's a remote Java process and a specific port on here, which is what we're going to be using to connect this debugger to it. So when you can create a new remote debugging application on here, which we add the source that we just pulled down, or that we just imported into that project as the reference, so all the breakpoints will work. And then we set the specific port to what we saw in the DDMS view. Now after clicking debug, you can see there's a bunch of errors in the project, but we don't care because we're not actually running the project. We're just using that as a reference. Now the application ran. Now when I click this button, Eclipse is going to pop up saying we hit a breakpoint and we want to switch over to the debug view, and click yes. We can see that we broke. But like I said before, the line numbers don't match up. So when the breakpoint hits, the application says we hit a breakpoint on this specific line number. So when looking at this view, if you can see on the bottom, it thinks that the breakpoint was on that line of code, but since our line numbers don't match up from the decompiled source to the legitimate source, it's not going to line up properly. But if we start stepping through the application, we can see that this is the method that we did want to break on. It does some stuff, and then it creates a variable string, and then iterates through some array, and continues. when we start stepping through this portion of the application, we can see that it's going to create a results variable and then an I like that exists just like where the breakpoint was hit, or where we wanted to break, which lines up directly with this method. Now, when we start stepping through it, we'll see the results start adding characters to that's going to be the hash of what we're actually wanting to see, and the I value increment. But since we had a exit breakpoint as well, we don't actually have to step through all this. We know that that string is going to return at the end. So when we play, it's going to hit the exit breakpoint, and we can look at the variable, and then we see the legitimate hash of how the application authenticates itself to the backend architecture. That was a lot of work to get very little stuff, but it showed me the way how cool debugging can be and how useful debugging could be when reverse engineering an application. To me, it seemed like it was like if you were using Immunity Debugger or Ally Debug or GDB to debug a binary, but it just gives you more information. Like, oh, here's the variables that are existing in this application at this point in time, and certain applications actually can call methods on them there. But not only can you create breakpoints on methods within the application, but you can also create breakpoints on core Android and core Java methods as well. So something like intent, or as you're going to see with this next tool, crypto stuff. So the way I found this technique was reversing an application that I was trying to find what the AES secret key was and the initialization vector, and it was very obfuscated code, and I couldn't follow it. It was that obfuscated. So originally I was going to write this tool that was going to be part of AutoTool that would allow you to do this type of stuff and just show you the variables similar to like Eclipse did, but without having to go through that whole process. But then I started thinking about this, and this whole idea was kind of bigger than just Android. It's the Java debug architecture. So I created a new tool called, with two tools, JavaTap and CryptoTap. CryptoTap just automates that and prints out any encryption-related information from a Java application, and allows you to attach to a remote process like we just did in Eclipse, or it allows you to launch an application just from the command line. JavaTap is kind of an abstract version of that. It allows you to just create a configuration file that just says enter your exit and what method you want to break on, and it just prints out the associated information. So I was going to create a video for this, but I've never done a live demo before, so we're going to try it out right now. All right, so I've got this Java application right here. This is the source for it. So all it does is takes. You guys see that, right? All it does is takes ciphertext and decrypts it, and then takes a plain text and encrypts it. It doesn't output anything, but the goal is to try to figure out, without having a source, how to figure out the initialization vector, the secret key, and whatever is encrypted. So when you run the tool, you can see that there's a bunch of command line options. Is that big enough? This one we're just gonna is part of this jar. So right here we open the jar, call launch, specify the class. This launch argument is just basically if you were going to launch a Java application, what arguments would you put after the Java command line? So dash class path, the same jar because the main method exists in there, and then this is the class that has the main method that we want to call. So when I run that, it's actively debugging essentially what we were doing in Eclipse before, except for looking for these specific things. As it runs, you can see it prints out all of the encryption information that's associated with this. This is a very simple example in what I was doing for testing, but if you can use this on more complicated applications and just run it and pulls out crypto keys for you. You don't have to do anything. Pretty cool, in my opinion. And then so that was just a Java application, right? And this is an Android talk. So again, wanted this to work on Android. However, this is what happens when you. So it's the same same source as what I showed before. It just put in an Android application that prints out something to logcat. Now, there's a command line option, a command line tool, which is right here, the AM application manager, that allows you to force the application to wait for a debugger before running. The command is shown on the next screen. But now when I run this, it's going to wait for the debugger. When I can use DDMS to see the port, and then when I call the crypto tap with the remote port, and look back at logcat and see bad things happen, really bad things. If anyone's seen a stack trace in Android before, this was a Java application, however it's crashing on hard, not on anything Java related. So there's no native code that was associated with this application, however it's throwing a SIG-7 crash. Kind of weird, but sent this bug to developers at Android and no one has responded to me, so hopefully they'll fix it soon. I have found another technique to do the same thing with other calls in the Java API that kind of works, but it's not there yet, so I think I'm going to, but then that version doesn't work with just the raw Java version, so I think I'm going to make 2 versions of this. Right now the crypto tap version that was shown in that demo will be available at the end. This was the command line option of the account manager that allows you to force an application to wait for a debugger. Like I was talking about before, there used to be in the dev tools of Android the ability to do that. However, they took that GUI feature away, but this is a way to do it from the command line. So again, thinking it from a developer's perspective, how can I prevent this? And again, I haven't found a way to. I may be doing this wrong, but in the Android manifest file, there's a debuggable option that I literally tested this yesterday. You can set it to false, and I would assume that means that you can't attach a debugger to it. Except for doing that exact same thing that I was doing before, allowed me to attach a debugger to it. So I would assume that's supposed to prevent it, but it apparently doesn't work. And even if you do have that option there, you can use APK tool to decompile the APK, modify the manifest file to turn that to true, and then repackage it and reinstall it. So AutoTool, like what I was talking about before, was kind of the start of why this whole talk exists. There's a whole bunch of other features in there, like live file browser, which allows you to see SQLite databases, text files, and hex files. So this is directly from the device too. It doesn't pull anything down. Well, it does pull stuff down, but it's behind the scenes. There's file system differ that allows you to scan the file system in 2 different points in time and see what files have changed on the device. An ability to visualize the Android manifest file, and it puts out, highlights key places on places you can look from a security perspective. And that's it. Again, my name is Matt Raleigh, Matthew at Montesano. There is AutoTool can be obtained on GitHub. The crypto tap is right there. The slides are there as well. And my one plug is that if anyone's looking for a job in security consulting, send me your email, New York City, Chicago, or Mountain View. Any questions? All right, well, thank you guys.